Good morning. I'd like to thank you for participating in the Amann Girrbach Zahn Dental webinar. As you can see, we've got equipment set up, and I wanted to show you what it's like to work with the Amann Girrbach equipment, and also get into each piece. We have 4 separate pieces that we're going to be looking at. We have the Smartbox X2, we have the Smartmix X2, we have the Giroform for pinning the dies, and then we also have the Articulator system that we'll be looking at. I just wanted to show you some of the differences. Let me just start by saying that the Amann Girrbach system is a complete system for creating your model work, and it has worked so well for us in the way we work, the expertise that we try to achieve, and it can do the same thing for you as well. Let me start out though by introducing myself. My name is Perry Carroll. I'm a certified dental technician. I've been a dental technician since the early 70s, so I guess that constitutes the fact that I'm antique. And also, we've had our own laboratory since 1984, so we've been around a little while. We go way back to where impressions were done with plaster and copper tube and rubber base and all this stuff. Some of you may not even know what I'm talking about. I hope there's a few old school people there that remember those days. But we've come a long way, whether it's digital dentistry or even the expertise in what we're looking at today and what we're trying to achieve. I'd like to thank Amann Girrbach for their support in the training center that we have here. I'd like to thank Zahn for putting this together, and thanks for all the help that you guys do. I really appreciate it. But let's just go ahead and get started and jump in and look at what we're doing as far as the equipment. The first piece of equipment is the Smartbox X2, and it has the liquid and powders already involved, and it just helps you achieve accurate measurements in all your mixes of stones, whatever you use. This is the old way that we all did it. I'm sure some of you used these before, and it's more of a kitchen scale. And if you put 100 grams of stone in here and you bump it, every time you bump it, it's somewhere else. So how do you get something accurate off of something like this? You can't. And then let me also mention something else that happened. A friend of mine in North Georgia has a laboratory, and he started having some remakes in his lab. And so he was trying to figure out, hey, what's going on? What's taking place that we're having remakes? He started looking at everything in the lab, and they just really couldn't find anything. And in his lab, there's some windows where you can see the rest of the lab. A lot of labs have walls, but those walls will be large windows. And he was standing there, and he looked, and the person in the model and die room was mixing the stone, had measured everything properly, but then they cut the water on, walked over, hit just a little more water into the bowl, and stirred, and he was like, oh my gosh, that changes everything. So the accuracy with the way we do things, or the measurements that we do, all that controls expansion in the stone, and we want it to be accurate. And that's what Amann Girrbach has done here, is create an accuracy that's just off the grid and really works well. So bear with me just a second. I want to get the computer over here so you can see a little bit better. I want you to actually see what's going on with this. Sandra, if you could come over here behind me just a little bit. I want to prop this up and just kind of hold it. All right, here we go. What I'm going to do is start it. Hang on, I aborted it by accident. Here we go. That's the first thing I wanted to show you. Let me explain to you what happened, because I did this the first time I cut it on. Let me move this so you can see. And this has happened several times with somebody, especially somebody that's new in the lab. First thing you notice, I didn't take the lid off of it. Needless to say, the water doesn't go in, nothing goes in. The other thing is that there is a cap on the bottom that also needs to come off. You need to keep this cap on, because this cap seals the powders, and as you know, powders that are left out absorb moisture from the air and change the expansion ratios. So that's what needs to take place. So Sandra, if you could hand it back to me now. That's good. Wait. Thanks. Now, I want you to see the way it's supposed to be done. Let me get a little lower. The liquid has gone in. The powders go in. Measured to exact amounts. Now let me get into it just a little bit. Hang with me here. Get back up where you can see. Sandra, if you could clean that out, please. Thank you. It's now mixed accurately, but let me get into a couple things about the unit that's unique. And one is that you can set the time for the liquid to start absorbing into the powders. What's important, I don't know, if you mix by hand, if you take a look, when you're mixing by hand, a lot of times when you're looking at the bottom of the bowl and you're mixing, there's always a little wad of dry stone down in the bottom that a lot of times is hard to get a hold of and accurately get mixed. And you keep working at it, and try to do it that way. If you allow it to sit for a few moments and let that absorb up, then when you start mixing, the mix does better, and it's a little bit more accurate because everything mixes together properly. On the Smartmix as well, there's about 20 programs for different types of stones that you might use. You may, like some laboratories, I know we do it a good bit, is actually mixing even our buff stones sometimes for cases that we're doing, we want to pull a vacuum on it and make sure the stone is a little bit harder. There's nothing worse than working on a case that's been poured with buff stone, a lot of times from a dental office, and the stone is just really soft. Matter of fact, we had a case just this past week. The stone was really soft, and we just flooded the entire model with sunacrylate glue to make it a little bit harder, and we were able to use it then, so it wouldn't destroy the model. The other thing is there's about, like I said, there's about 20 programs, and also the setting on the time for it to sit is anywhere from 10 to 30 seconds. We set it at 10, and you can do whatever your needs are according to what stone you're actually using. So that pretty much is it with the Smartbox. Now let's get to the Smartmix and talk about the mix itself. What I want to do, mixing stones, I guess everybody mixes stones, and everybody, it's just mixing to some people's extent. But there's a couple things about this unit that's different. One is that it has 2 vacuums and 2 pumps, which speeds up the vacuum quicker, which means there's more vacuum taking place for your stone. So you get more air out of the stone. So that helps a good bit. And then also, everything the way it fits together. Let me just go ahead very quickly. We'll go back through it one more time. You've already seen this up close. You saw the water mix ratio. Put the water in. Swallow water. Okay. Pour this out. It didn't quite do like I wanted it to. Now, I had bumped it. Sorry about that. I changed it and didn't realize it. There we go. Now we got the correct amount of water. It's going to notify me in 10 seconds. And automatic mixes for me. For resin rock, we have the time set at 30 seconds. Here we go. Okay, Sam, can you come in? I have an assistant with me today. Thanks. We're not going to try pouring up the model because there's several things I want to get through with you as well. And so that pretty much is the Smartmix, the X2. Again, the accuracy in all of this, especially with being able to get the air out quickly and having it measured properly, all of this up to this stage works extremely well and it's extremely accurate. It helps us achieve the results that we want to achieve in the lab. The next part is getting our model and getting the model poured and the die system. Let me explain a couple things about the system that makes it a little bit different. Most of us know that we have expansion in our die stones. Any stone that we mix, it goes through a chemical process from, even if you're talking about something like concrete, even concrete has an expansion and contraction between its chemical process and cooling and things like that. There's always a heat that's involved there. And for us in the laboratory, that's where part of the problem is the expansion of the stone. We have to try to match the expansion of the impression materials. We have to try to match the room temperature. Even in our laboratory, we did a little bit of experimenting with room temperature. This was years ago. And we realized that room temperature had a lot to do, especially in waxing, that had a lot to do with the way things fit. So any kind of details that can affect your materials can cause some problems. So one of the things about die stones is the expansion. We pour a model and it pours up solid. That solid model, depending on its mass, shrinks and contracts and expands according to what we want it to do. We can change the ratios sometimes and change the expansion, but you really want everything kind of set and have some little bit of rules for your plaster department, whatever, to be able to set these things and have a consistent working system all the time. That's what, all of this together, that's what helps us do that. But the thing about this is you're actually pouring your model and pinning your model at the same time. Now, many of us used to do that years ago. You're also creating the base at the same time. Years ago, we used to pour models and we would mount the pins on pegs or something and all kind of things like that to try to do it. And that was the old school way. Some of you may not even be able to picture that. But that's the way we did it back then. As far as now, when we have a model that we want to pour up, if we want this accurate model, what can we do? How can we change it? And this is what's great about what AG did for us on this, is they've got it to where you actually separate your model prematurely. Now, I guess that word may not work right with what we're trying to do, but we take the model out and we actually saw it out before its expansion has completed. Or maybe not before the expansion is completed. We do that before it completely sets. And let me show you what takes place and why it becomes so accurate. As you can see, this is the base itself that has already had the pins put in. This is my model. This is actually a, what is this, 8-unit crown, all ceramic, that we did out of Emax at some point. And as you can see, if I try to put this in and I get it in place, it doesn't quite go down all the way. I guess you can see that pretty good. That is because expansion has taken place in this model. Once you saw all these out, I left it unsawed, but once you saw these out, they go all the way to place. But that's the whole purpose in this system, is getting these sawed out to match the expansion properly so that we get an accurate model. If you just did this the old school way, just like this model here, and did it old school, those 3 units really aren't accurate. They're close, and some people would say close enough. Personally, I don't like close enough. I like it for it to be perfect. And sometimes that gives me a headache. But anyway, that's the way we want it to be. And this actually allows us to do that. Once all the rest of these are sought out and everything will go to place, it will be way more accurate than if we'd done it the old school way. And that's what's so unique and interesting about the system. But now let me show you a couple other things that really work well about the system. And I'll show you how to set up the impression, all that. But since we have the model here now, we can show this, and it makes it a little bit easier. As you can see, let me go ahead and put this in. This isn't quite going down all the way, but this is something else that's really neat about the system that works out well, at least for us, is the fact that once you get the base, let me put the mounting plate on. You can imagine, you can already see the difference in the heights from this model, from the way we did this one. But you can see the difference in the thickness of the base. And this already has a mounting plate on it as well. You can imagine this with some stone and a mounting plate, the heights would be, you know, almost like this, and it'd be a huge difference. Well, I don't know how many times you've had it happen. You've got a face bowl mounting, and the model is so high up in the articulator, you have to try to grind off the base, you grind off the pins, you do everything you can think of to get this short base up at the top, and it's actually an issue. You know, you wound up with really, really, really short single pins sometimes, or you ground pins, you cause a lot of vibration in the model. You know, it's just not a good way to have to try to do it. With this, you wind up able to close your articulator, get a really good mounting even if the model is higher. So that's one of the just small things about doing this that's really neat, and I really like about the system in the shortness of it. So now what I'm going to do, I'm going to move the computer over just a little bit so you can see a little bit better. And get it turned in like this. Hope everybody can see real well. What we have here is an old 5-unit bridge impression. I wanted to show you the technique on what takes place, how to put all this together to get this pinning started. First off, and I want to show you how you like that. I did that yesterday working with some stuff with this. So be very careful with it. This comes with your Amann Girrbach system, so be careful with it. So anyway, you're trimming everything off flat, getting some things out of the way, maybe on the outside edge. You'll wind up having to trim a little bit in here. Already have this prepared. Let me get it back where you can see it. This, of course, is the holder for your impression, and it also makes it where you can go to your pinning drill. This is just silicone type putty. It's available from Amann Girrbach to use with the system. You'll get some, you get a system. And so the impression is then mounted into this. We want to fill in a few voids. Then you'll also go around and make a rim. Like so. This piece here that's clear is used to get everything set up here and for you to view, to be able to make sure everything is in its place. And also, because it's clear, you're able to, let me just put it in place real quick. Push it down, get everything pushed up to it accurately, fill in any voids from the sides. And it also helps you visualize and see, this is what your base, the shape of your base. So if you need to move the impression around or move it over, you're able to do that and see that everything is where you're going to drill is going to be accurately in place. So let me take this one off. You'll have some areas even toward the back. Let me point with this. This area in here that you'll also need to fill in just a little bit. Stone will run out and get all over the place if you don't. So we fill these in. Push this back a little. Put a little tad more here. All right. Then our clear one back on. Double check everything. Take your piece back off. Something else that we normally do is take something. We look at where we're going to be pinning. We have a die here. We have a ponic here. We have a die here. Ponic, a working die, and then maybe a couple pins over here just to stabilize all the adjacent teeth and the other side of the arch. Now, this is our holder for our base. It has, up here, if you can see that pretty well, has something to catch the front. Then we have a screw at the back that will hold the back into place. You put the front in, you'll see that this slot doesn't come all the way down. You want this to catch up under. Get it in, then just hand tighten, and hand tightening is enough. This is the bottom side. So you flip it over. This is the side that goes for the mounting. So this, if you'll notice, let me hold this in place a little bit, has two holes here. Those two holes line up with these two pegs. And so you put this over, lock it into place. It kind of snaps just a little bit and goes in. Now, we can view everything. We've got our lines to remind us of where we're actually working. Then, let me turn this just a little bit. Goes on. Let me show you, let me bring this up just a little bit. Let me show you a couple things here. Sorry if it's moving around a little too much. These are magnetic plates that engage once you start the drill. There's two buttons on each side. There's one like this on the other side exactly. And so once you put it in place, you touch these two buttons one time, and you can see there is a laser. Let me see if you can see it. I think you can. You can see the laser on the top. And I've pushed this around a little. Let me take that back down. All right, now we put our laser into the areas that we want it to pin. Hands free, it drills a hole. Move it over just a little. Hands free, it drills a hole. Same for the ponic. Hands free, it drills a hole. I'm going to just put a single hole in some of these just to save a little bit of time for us now since we're doing this, because I want you to be able to see it. We probably put more holes in this, but just for the sake of time, as you can see now, we've got all our holes drilled into the base. So now, turn it in just a little. Now we're going to take this apart. Take our base out. We put our pins in. I won't put them all in for sake of time, but then this will fit on here and all the pins go to the right place. Everything fits perfectly. And what you'll do, just like you'll mix your stones, you'll pour your model, you know where the bottom of the base is by the rim that's here, so you fill it up and just, you don't have to just overdo it, you don't want to run it out, but just fill it up just enough that it's right at the edge and just minutely overfilled. Then you'll mix your stone up and apply stone around your pins so that you won't trap any air against the base. You want a good, clean, no bubbles inside. Once your stone is here and once your stone is applied here, then you're able to seat it down and you let your stone set. The trick to this whole thing is getting back to this model. Let me get back over here now. The trick to this is the fact that you get this model separated in less than 30 to 35 minutes. The final set on most stones like this is about an hour. The trick, though, is to get this out before all this expansion takes place that you're fighting with to make sure everything is accurate. So you get that out, you get your die sawed, and then you can put them back in, and you've solved your problem of the expansion making your model inaccurate. Now, I know we're splitting hairs, and this is so close, but I don't know what kind of doctors you people have, but I've got doctors that when they still are old school and still try in bridges before we put the porcelain on something we cast, and they take x-rays and they look at those margins. Now, not every doctor does that, but you really got to get it close and accurate to be able to achieve those kind of results. And all of this helps you get to that point. Once your model is poured, and of course you get it separated, and you get your model and die done, the next stage then, of course, is the mounting and the articulation. Now, let me bring up one or two really quick things. These are fuses that we picked up at, I think we got these at Lowe's or somewhere. You probably go to Home Depot or whatever electrical store. The fuse that comes with the Giroform unit is a German fuse. The electrical current in Germany is a little bit different. It's not a whole lot different, but it's enough that the type of fuses that they use won't work that well with American current. Now, you might use it for 6 weeks and it not ever blow a fuse. And then the next day, it blows every fuse you put in there. So I want you to know ahead of time what you need to do on the actual amperage for the fuse is what comes from Germany is a fast breaking fuse, and it also is at 2.5 amps. And Amann Girrbach has the information as well if you don't get it written down. What you need to do is double that. You need 5 amps, and then it works like anybody's business. And there's no problems with it at all. And of course, we had to do that with this one. We got started using it, and it worked great for a while, and then next thing we knew, we were blowing fuses. And so Amann Girrbach shared with us, that what we needed to do and how to solve the issue. And that's what you'll need to do is get a double amp, 5 amps instead of the 2.5. Now, another thing that I wanted to just show you, some of you may think this is almost silly or something like that, but let me show you one thing. When you're pouring these models, they're all mounted in this jig, and moving that jig around and trying to get the stone in just right. Sometimes it's a little tricky, but we came up with this. Most of you recognize what this is. This is the tissue silicones that you can use. There's several different brands. I think the kind we use is from Ivoclar, the Gingitech, and that's what this is. But this is so soft. If you dip it in the stone and use it, you can actually push your stone around in there, and the thing is you're holding this. Let me just pick this up. You're holding this and trying to get stuff in there accurately without having any bubbles. This is a big help. So this is something most of you have laying around, easy to use. You don't have to buy anything. You've already got it. So anyway, just a little tidbit there. Another thing that I wanted you to see and bring this out, many of you know that when you're pinning dies, especially on anterior cases, I need something to point with. We'll use this. Many of you know this area in here where you're going into the vestibule and the way that bone is curved in there, this is an area that is weak sometimes depending on how and what system you're using the pin with. So how do you eliminate this problem of this being thin and a possibility of something breaking? You know, like this is a 3-unit bridge. How many times did we take it on and off, you know, and put pressure on this die? Put pressure on the die. Well, the one thing that you can do on an anterior, especially an anterior case, is when you're getting ready to work with this case, you just push this down further so that you get a little more of an angle to the impression. That means you've got it turned and you're drilling in. What happens is, how can I hold this so everybody can see? There we go. The long axis for this tooth is actually more like this. So if we pour that stone or trim the base so that it's turned this way, and we actually drill up through it at a different angle, we've created more strength up in this forward anterior position, so that makes it a little bit nicer. So if you're working with anteriors with this, pushing it down a little further in the anterior helps you turn that and allows you to have a different angle where you're pinning more with the long axis of the actual tooth and actually creating a stronger die. So just a little trick right there. All right, so now let's get to the actual articulation of what takes place. And of course, you start, hopefully, depending on what kind of case it is, if it's a single unit, you're probably not going to get a face bowl, which is, you know, okay, not everybody does face bowls. We've got one doctor that even a single unit is face bowl mounted. And I actually would probably do that on everything. But it just creates the accuracy that he wants, you know, what he's trying to achieve. Most of the time it's a larger complex case that we're using this with. But these cases, let me get this jig real quick, have a jig that goes in, there we go, and I got to get it out. Still in the package. Hang on. And a bite fork. This one has compound on. This is the one from AG. And of course this goes on here. And the bite is taken into the face bowl. Adjustments are made here. I really like the way AG configured this. There is one tightening screw for the whole jig. I know there are some other systems, and articulator systems, you have to tighten one here, you have to tighten one here, and then you have to tighten one down here. Being able to just get it in place and tighten one screw makes it a whole lot easier. So anyway, once you have this in place then, this jig then comes off and goes on your mounting jig. And as you can see, here's a case that's already mounted. This jig, of course, fits like this, like this. And as you can see, I've got some stone here, mounting stone, and got this jig in place. Now, from here, come on, take this back off. Once this is set, this whole piece comes off. And the case can be mounted on the articulator. And so this is, we have doctors who do it both ways. We have doctors that will already have this mounted on the jig and they just send this whole piece, or they send us the bite fork and we actually mount it on this to put it on the articulator. Now, let me show a couple things here. Let me show you the 3 articulators I have with me. Let me show you these first. This is of course is not adjustable, and a lot of it's just kind of a workhorse. If you got single units, 3-unit bridges, or maybe a denture case or something, you may be using this articulator in your lab or something similar. Then you have, of course, a fully adjustable articulator, and one of the things that I love most about this articulator is the carbon fiber frame, which makes it very light. you compare this to some articulators, they're just really hard to hold. I wind up trying to prop them on the bench to work with them. I think, I mean, you probably do the same way. This one's so light, holding it while working on it is very, very easy. That's one of the things I like about it so much. But the real thing about the way the AG system works is really neat to me. In our lab, we wind up calling this the Mule because it just really works, and it works hard, and everything is mounted on this Mule. Nothing is mounted on the articulator itself. And the reason we do it that way is that you'll notice there is no incisal pin that slides from 1 millimeter, 2 millimeter, 3 millimeter, or whatever adjustment. This is always at 0, and it's perfectly matched with the other articulators. There's nothing worse than be working on a case. Now, I don't know about you. You know, some cases you don't have the problem, but we do a lot of complex full mouth reconstruction. And on these cases, a lot of those type cases, we're opening the bite. And there's nothing worse than sitting down on an articulator and looking at it and realize it's open to 2 millimeters, and you're thinking, okay, wait a minute, did we open the bite or do something, and you know, where did we start out at? There's never a question of where we started the articulation. It was always at 0. And that makes it so easy because if you're working with a case, there are points where you get to the case and you're scratching your head how to complete it or what to do. And sometimes you're looking at, maybe you're in the diagnostic wax-up stage. Sometimes you want to back up to 0 and you want to know where you started from. And you'll always have that if you use the system this way, and always mount everything at 0, which makes it really nice. And other times, I don't know if you've ever had to do it, maybe you got everything together on your articulator, and all of a sudden notice when you closed it down, all of a sudden the pin is this high and the mounting plate is hitting the top of the model. Again, that's why I like this system, because everything is shorter coming down from the top. And actually these articulators, I haven't compared it to every articulator system, but on the few systems I've compared it to, this opening in here is about 10 millimeters higher. Matter of fact, than the old Artex articulator is about 10 millimeters higher, but even compared to some others. I even measured one this morning. I won't mention the name of the articulator, but this one is about 10 millimeters more opening than that one is. So if you have large cases too that are implant cases, you know, the implant models are much more, so it gives you a little bit more room. That's nice about the system as well. All right, now, here's system articulator. Backwards. All right. Now, we have it's 11:37. In the system and the way you work with it and put everything together, the one thing I like about it as well, and I may kind of mention this a little bit, is the fact that it is an entire system. There's no parts from somebody else. There's no technique or whatever from somebody else. All this stuff is completely one system. So if you do have a question, you're calling somebody that knows the entire system. And I like the fact that there are dental technicians that you can contact that are familiar with this with AG that understand the entire system. But you know, I know a couple of people that have milling systems that they've got software with one person, they've got the computer from somebody else, they've got the scanner from somebody else, and you've got a mill from somebody else, and it's just hard to get it all to come together. It's even like the difference between Mac and Windows-based systems. You can call Mac, and they can almost give you any answer about anything, but if you call Windows, you got a question and say, well, that's the software, you're going to have to call Microsoft. Well, then Microsoft sometimes will turn around and say, well, I'm sorry, you're going to have to call, you know, call the actual Dell, the computer manufacturer, for that. And so you get it all crossed up. Mac's a little bit easier. This system is like that. AG is like that. Their systems are complete. And so that makes it easier for me as a dental technician to connect with one help desk and work on all of it. And you know, if I need to make changes, if I'm doing something wrong, I'm learning from somebody that knows the entire system, which makes it great for me. Also, the changing out the, let me see if I can get it just a little bit closer. I do want to show real quick changing out. I think you can see it pretty well. you have a small bar that goes in from the side and locks into the spindle, and then you have a piece here. You just give it a quick twist, it unlocks it, you take the pin out, and you take the drill bit out, and you're able to put the new drill back in. Also, adjusting the height on this, it's just a simple screw in the bottom. Once you get your bit out, of course make sure you cut your power off, then you can take and adjust that screw according to the height. You know, drill a plate a few times just to see how it works and the height, and you'll know whether to lower or raise it as well. All right. Well, I want to thank, again, Zahn and CAP and CMC. I want to thank Amann Girrbach for, you know, all the support and everything we're doing here. And I hope you've gotten some good knowledge that helps with what you're trying to do with the system, or learning about the system, or decisions you need to make for it. I do want to say, you know, please don't hesitate getting a hold of me for any kind of question at all. Even if you think of something later, please don't hesitate to give me a call. You can call the laboratory, or you can call my cell. I think that they have the information through, you know, at Zahn or CAP, where you can get a hold of me. Please feel free to do that. And thanks for showing up, and thanks for participating. And I appreciate everything. You guys have a great rest of the week. Thank you.